Look at this circuit closely. We have multiple resistors, multiple loops, and multiple voltage sources. Suppose we want to find the current passing through and voltage drop across each of these resistors. Then, what should we do? Two laws that are fundamental and form the backbone of circuit analysis in this universe are Kirchhoff's current law, or KCL, which we also call as junction rule, and Kirchhoff's voltage law, or KVL, which we also call as loop rule. KCL says that the total current entering a junction or a node is equal to the total current leaving it, because charge cannot appear or disappear at a junction, and KVL says that the sum of all voltages around any closed loop in a circuit is zero because the energy is conserved. As a first step, we choose a reference node, also called the ground, and we assume its voltage to be 0 volt. This node serves as the baseline, and all other node voltages will be measured with respect to it. For this case, let us select this node as 0 volts. Before we move further, always note that if we have a resistor and a current flows through it in this direction, then the resistor acts like a voltage eater, and this is called a voltage drop across the resistor. The voltage drops in the direction of the flow of the current. So, if the current goes left to right, the left side of the resistor is at a higher voltage, and the right side is at a lower voltage. The amount of voltage it will eat depends on the value of the resistor and the current flowing through it, and is given by V equals I times R. For example, if a 2 ampere current flows through a 5 ohms resistor, it will eat 5 times 2 or 10 volts. So, if this node is at 15 volts, then this node will be at 15 minus 10 or 5 volts. Great! Now for every other node in the circuit, we assign a variable to represent its voltage. If this is 0, and here we have plus 17 volts, then this node will be at 17 volts, right? Now because of this resistor, there will be a voltage difference between these two nodes. Right now, we don't know this difference, and therefore we will label this node with voltage as V sub A. Then we will label this node with voltage as V sub B. Now if this is V sub B, so this will also be V sub B, because there is nothing here except wire, whose resistance is assumed to be 0. Then here we have plus 5 volts, and therefore this node will be at VB plus 5 volts, right? Next, we apply KCL at each